So I'd like to look at a couple examples from 6.4, confidence intervals for variance and standard deviation. So question 8 says, use technology to construct the confidence intervals for population variance and population standard deviation. Assume the sample is taken from a normally distributed population. So we're given the confidence interval is 0.98 or 98%. Remember, S stands for the sample standard deviation, and N is the sample size 17. So we actually can't use technology because the technology they're talking about is more like Excel and things like that. And we've been mainly just focusing on the graphing calculator. So we're going to have to rely on tables to do these questions. So ignore the technology on this question, except for the fact that we're going to use a calculator to do some of the math. So remember, to do the confidence interval, we need to know the degrees of freedom, which is this n minus 1. So remember, degrees of freedom in our example is going to be then this, let's see if I can get this thing to work here for us. Let's see here. Cool. So the degrees of freedom is going to be the 17 minus 1, which is going to be the 16. Now, remember, to use our chi-squared distribution table, remember the chi-squared graph is not quite symmetric. Remember, 0 is actually over here. So both chi-squared L and chi-squared R are both positive values. Now the confidence interval is still this 98%. This 98% is this value in between here. So this 0.98 is this value in between here. So also what we pick up on is these outside areas are still going to be congruent or equal. They're still going to have the same value here. So my drawing is not perfect. So this 98% is going to be shared equally out here. So if this is 98%, that means there's this 2% that's going to be shared equally. So that means there's going to be 1% out here and this 1% over here, if you will. So if you divide 2% by 2, that gives you this 1%. So notice how this is 98% here, 1%, and 1% makes that 100%. So to use the table, remember that what we have over here on this side of the table, let's get this thing to work for us here. So remember what we kind of talked about as a way to kind of not use as much math is this table kind of gets broken into two pieces. The chi-squared R values are over here, and the chi-squared L values are over here. So notice how the chi-squared R is this 0.01. So what we pick up on is chi-squared R. Let's get this all to work for us here. So chi-squared R. Notice how if we look at our table, the degrees of freedom is 16. If we come across here, we're seeing that chi-squared R is just 32. Just simply 32. Now chi-squared L, notice how we have symmetry. Notice how if we go from the middle here, if we go 1, 2, 3, 4 over to the right, chi-squared L is going to be 4 to the left, 1, 2, 3, 4. So it's going to be this 0.99. So notice that they have to add up to that 1 as well. So 0.99 and 0.9 or 0.01 add up to that 1. So this kind of tells me that I'm on the right track here. The chi-squared L is actually this 0.99. So if I come down through there to the 16, I'm getting this 5.812. That's one way to kind of simplify the math a little bit, is use the symmetry within the framework of the table itself. So 5.812 would be the value there. So what I can now do is I can build my confidence interval using this information. So we pick up on that the degrees of freedom is the 16. But notice how this is variance. And up here, they gave us standard deviation. So I still have to kind of figure out what S squared is. So if I do 37 squared, so it looks like I'm done with this table. Got all I need out with this table. Let's switch over to the calculator. So if we go down to 37 squared, that'll actually give us our variance for the sample. So this 1369. So I could put that into my formula, 1369 here. Then if I divide it by chi-squared r, which is the 32, then you're going to have less than, and then your population variance is going to be here. And then over here, you're going to have then your degrees of freedom, the 16. And then this is going to be, again, your sample variance. If you watch my videos, I apologize. I still keep saying those wrong. But yes, we know what they are. Just sometimes we mispronounce ourselves. Apologize. And then notice how we need our chi-squared L critical value here. So 5.812 goes into that spot. So all we got to really do now is put this into the calculator. So what I'm going to do is just put the numerator into the calculator. 16 times this 1369, get that answer. Then I'm going to divide that by 32. So it's going to give me my left boundary. So 684.5 is less than here. Then if I go up there and just copy that number there, that's the numerator. Then if I divide that by chi-squared r, which is the 5.812, that'll give me my right boundary. And that's going to be 3,768.75. I think they go two decimal places. I can't, again, remember that. Now, that would be the confidence interval. And again, I think we were 98% confident. So I'm 98% confident that the population variance is going to be between these two values. Now, to get the confidence interval for the standard deviation, we're going to have to take the square root of these values. So if we take the square root of this here, that's going to give me my population standard deviation. So what I'm going to do is just go up here and, I'm going to take the square root. I'm just going to go up here and copy this value in and hit enter. That's going to give me then 26.16 for that side. And then again, I'm going to take the square root and I'm just going to copy that number in, paste it in there. It gives me then my other side of my confidence interval, so 61.39. So that's going to be the confidence interval for my standard deviation. So this would be my population interval for my population variance, and this would be my population interval, my confidence interval, I should say, for my population standard deviation.